So let's just show you. It's a lot easier to show you than talk about it. What if we have 2 1/3, and we're adding to that 3 1/3? All right. So we want to add these guys together. Of course, we can add them. We've done this problem before, actually. But let's go ahead and convert each of these fractions into improper fractions. And that's easy to do. We've learned that skill in the past, so if you don't know how, go ahead and pick up the previous lessons on how to do that. The way you do it is 3 times 2 is 6, plus 1 is 7, and you always write it over the same denominator that you started with. Here's 3 times 3 is 9, plus 1 is 10, over the same denominator. Now you have 7/3 and 10/3, and you can add these together because we already have a common denominator. We keep it. 7 plus 10 is 17. Now this is the answer, 17/3. That's the answer, but you know this is improper. So typically when you're adding mixed numbers, you want to get the answer back in mixed numbers, so you want to convert this back. How many times will 3 go into 17? Well, 3 times 6 is 18. That's too much. 3 times 5 is 15, right? It's 15. The difference between 15 and 17 is 2, and it'll be over 3. So we get 5 2/3. That's the answer. All right, so again, we convert to improper, add, and then convert back to mixed numbers. What if we have 2 1/3 plus 3 1/4? All right, so in order to do this, we just convert each one of these into improper fractions. 3 times 2 is 6, plus 1 is 7. Write it as 7 over 3, 7/3. This one, 4 times 3 is 12, plus 1 is 13, and you write it over 4 because the original denominator was a 4 there. Now, you want to add these together, but you can't do it quite so easily because you have a 3 and a 4. It goes back to that basic rule that you have to have the same denominator in order to add fractions. So what we're going to do is we'll transform both of these into a common denominator. We've done this so many times, you should see that 12 is the proper common denominator here. So we'll have 7/3, and we'll be multiplying this guy by 4 on the bottom and 4 on the top. The reason we're doing that is because on the top then we will have 28, and the bottom, 3 times 4, will have 12. Now let's transform this one. We'll have 13/4, and we'll multiply this on the bottom by 3 and the top also by 3. So again, 4 times 3 is going to be 12, and on the top, 13 times 3. 13 times 3, if you do that multiplication, you'll get 39. 39. All right? And so we can now add these guys. Because we have two fractions, the 12 is the same denominator in both cases. So what I'm going to have is the 12 come along for the ride. And then what we're going to have to do is add 28 and 39. Now, if you can't do that in your head, just go off to the side. Everyone has to do this and add these guys together. 9 plus 8 is 17, so put the 7, carry the 1. 2 plus 1 is 3, and then that plus another 3 should give you 6. So you're going to end up with 67. So the top here, by adding the numerators, is 67 over 12. Now that is the right answer, but this is an improper fraction, so we want to convert it to mixed. All right, convert it to mixed. So we need to figure out how many times will 12 go into 67. Well, we know that 12 times 5 is 60, and that's about as far as you can go without passing up 67. So we know this is going to divide actually 5 times, and that's going to give us 12 times 5 is 60. The difference between 67 and 60 is 7, and you always put it over the same denominator. So what you get is 5 and 7/12, and that's how you do that. So now we're starting to combine lots of rules together. We have to know how to go to improper fractions, then we have to know to find a common denominator, then we have to add them, then we have to convert back to mixed numbers. And this is why math, you know, builds upon, every single topic and skill builds upon the previous. What if we have 1 1/6 plus 2 2/3? And we want to add these guys together. And we want to do it using this method here. So let's convert these to improper. So this guy, 6 times 1 is 6, plus 1 is 7, and write it over 6. 3 times 2 is 6, plus 2 is 8, and we write it over 3. Now we look at these two fractions, and we see we have a 3 for this denominator and a 6 for this one. We get awfully excited because we know that we can just transform the bottom fraction. And so we'll have 8/3, but we know that if we just multiply this one by a 2 on the bottom and a 2 on the top, we'll get 16 on the top and 6 on the bottom, which is exactly the same as this fraction. We're not going to change him at all. This will be 7/6. Again, we're just trying to get a common denominator. Now we have that. And so we keep the 6 along for the ride. 16 plus 7 is going to give us 23. 16 plus 7 is going to give us 23. Now this is the answer, but it's improper. So how many times will 6 go into 23? Well, 6 times 4 is 24, so that's too much. 6 times 3 is 18. So 6 times 3 is 18. The difference between 18 and 23 is 5, and then we write it over the same denominator. So we get 3 and 5, 6, and that's the final answer. Same steps. Every time we do it, we're just practicing our skills. None of this stuff is changing. It's just we're getting practice with different problems. Final problem, 4 and 1/6, and we add to that 2 and 3/4. And we're going to do it by changing these to improper fractions. This one, 6 times 4 is 24 plus 1 is 25, and we make it over 6 because that's a 6. This one goes 2 times 4 gives me 8 plus 3 gives me 11, and we make it out of 4 because this guy's a 4 down there. And now we want to add these, right? But we can't add these because we have a 6 and we have a 4, so we need to find some kind of common denominator. Now, of course, I told you the bulletproof way of finding a common denominator is just, we can just multiply 6 times 4. We know 24 could be a common denominator for both of these fractions. That would be fine. I could multiply this one by 6, and I could multiply this one by 4. That would give me 24 as a common denominator. That's fine. But we also look for something smaller and try to find the smallest common denominator that we can, just to save a little work and make it a little easier. We also know for 6 and 4 that 12 could be a common denominator because 6 times 2 could give me 12 and 4 times 3 could also give me 12. Working with smaller common denominators is going to make us get the problem done faster and with less work. So let's change this one. We'll have 25 over 6. And what we'll end up doing is we'll multiply this by 2 and this by 2 because we're trying to reach 12. So what we'll have on the top, 25 times 2 is 50. On the bottom, we will have 12. And then over here, we're going to transform this one by taking 11/4. And then we'll multiply this times 3 and this times 3, again trying to reach 12. 11 times 3 is 33. 4 times 3 gives me 12. So now we can add them because we have a 12 for the denominator in both cases. So we keep the 12 along for the ride. That just kind of hangs out. And then we add the 50 and the 33, and that's going to give us 83. So the answer is 83/12, and that is correct. We could circle that, but we typically want to convert it back into a mixed number. So how many times will 12 go into 83? Well, we think the answer is 6. 12 times 6 is 72, right? So we're going to make it a 6. So it goes 6 times because 12 times 6 is 72. The difference between 72 and 83 is 11. The difference between 72 and 83 is 11. So that's going to go here, 11. That's what's left over, and then we always make it over 12. So the answer is 6 and 11/12. This skill going from here to here is just converting from improper back into a mixed fraction. We've done that many times, lots of previous lessons. So go back there if you need extra practice with that particular concept.